Hello everyone, I'm Frank, and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Descending Arrows, and it's by Vithic. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. We have descension arrows, or descending arrows, I guess, where digits along an arrow sum to the digit in the circled cell, sorry. And they must, the circled circle is very interesting, and they must ascend away from the circle. For example, a sequence of 6, 3, 2, 1 is valid, where 6 is the circled cell, circled digit, and 1 is on the arrow's pointer. So the digits going away from the circle must be continuously decreasing. And the digits along the arrow sum to the digit in the circle. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, so because they must be decreasing, these are very restricted in what they can be. Because for one of these to be obviously, these have to be the smallest of the digits here. And if you have, the only way you can have 3 digits adding up, where it's always decreasing, which means you cannot have the same digit on the arrow, is the smallest digit can only be 1 or 2, guaranteed. For 3 unique digits. And since they're always decreasing, they have to always be unique. So, this must be 1 or 2 here. This for 3 digits here, this is 1 or 2. For 3 digits here, it's 1 or 2, 1 or 2, 1 or 2. Well, if we have a 2 here, that means it must be with 2, 3, and 4 to add up to 9. So then, since we have a 2 here, we're guaranteed a 3 here. With a 2 in one of these has to be 3. And then one of these must be 4. So one of these is 4 there. And we know one of these has to be 9. One of these has to be 9 because of this 1-2 pair here. This is 1 or 2. We have 1 or 2 being there. We don't know what these are. So this digit has to be greater. These digits have to be greater than this. So for 3 unique digits, the second digit has to be either 2 or 3. Because you cannot... anytime you have 3 unique digits adding up to a single digit, no matter what, you have at least 2 of those digits are from 1, 2, and 3, right? 1, 2, 3 obviously adds up to 6. That's 3 digits from 1 through 3. 1, 2, 4 adds up to 7, obviously of the 1 and 2. 1, 2, 5 add up to 8. 1, 3, 4 add up to 8. You have 1 and 2 and 1 and 3 there. And to add up to 9, you have 1, 2, 6, 1, 3, 5, or 2, 3, 4, which requires 2 digits from 1, 2, or 3. So this has to be 2, 3 as a pair. And this must be 2, 3 as a pair also. So this has to be 2 or 3. This is 2 or 3. This can't be 9. Because one of these is guaranteed to be 9 in this box. So therefore that requires this to be a 1. Because to add up to any with 3 unique digits adding up to a single digit, it always has to be 1 plus 2 other digits if it's not 9. Because 1, 2, 3 adds up to 6, 1, 2, 4 adds up to 7, 1, 2, 5 adds up to 8, and 1, 3, 4 adds up to 8. So this can, okay, so this is 2 and 3 as a pair. We have a guaranteed 4 here. So this could be 3 and 4, or it could possibly be 4 and 5. Because we know one of these is 9. So the other one cannot be 9. So you have 2, 3, and 4 adding up to 9. The 1 and the 2 could be with 3 to add up to 6, or it could be with 5 to add up to 8. We don't have a 4 available because we have to have 2, 3, and 4 there. This 1, 2 pair eliminates 1 and 2 in the rest of the box, so this can't be 2. That's 3, which makes that 2. This has to be less than 2, so that's 1. This 3 eliminates 1 eliminates 1 here, so it's 2. This can't be 2, it's 1 there. So this must be 2, 3, and 4, adding up to 9 there. And again, this can't be 4 here, so this must be 1, 2, 3, or 1, 2, 5, adding up to 6 or 8. We can't have the 4 there, and we can't have 9 here. So 4 eliminates 4 from being there. Therefore, the 2, 3, 4 adding up to 9 has to be here. So this is 4, that's 3, that's 2, which makes this 1, 2, and again, this has to be 2, 3, 4 adding up to 9. This could be 1, 2, and 3 adding up to 6. Or 1, 2, 5 adding up to 8. This again can be 6, 7, or 8 here. We could have 1, 2, 3 adding up to 6. You cannot have 1, 2, 4 adding up to 7. Because 4 can't be here because of 4 in the column. And we can't have 1, 2... We could have 1, 2, 5 here adding up to 4. Or adding up to 8. You cannot have 1, 3, 4 here adding up to 8. Because of 4 in the column. So this must be 1, 2, 3 adding up to 6, or 1, 2, 5 adding up to 8. Which means this is a 2 either way. 2 eliminates 2 here, so it's 1. Remaining digits in column 3, we have 6 through 9, but this can't be 6 or 8 or 9 because of the 6, 8 pair in the box and the 9 in the box, so this must be 7. And 7 is the sum of either 2, 5, which this can't be 2 because of 2 in the row, or 3, 4. We can't have 1, 6 here because of 1 in the box, so this must be 3 and 4 adding up to 7. 3 eliminates 3 here, so that's 5, which makes that 3. 1, 2, 5 adds up to 8. So that makes that 6, which is 1, 2, and 3, adding up to 6 there. That leaves this digit as a 2. We're the only possible digit left. And 1, 2, 3 adds up to 6 there. This can't be 2. And it can't add up to 9 because of 9 in the box. So this has to be 1, 3, and 4, adding up to 8. Remaining digits of row 6, row 7, it's pretty limited. Row 6 is 1, 5, and 8 remaining. We cannot have 5 and 8 adding up to a single digit, so we have to have 1 on the arrow, and that's the smallest digit, so this is 1. 1 and 5 add up to 6, and 1 and 8 add up to 9, so no 1 there. We have 6, 7, and 9 remaining in row 5. In the central box, we have 5 and 7 as a pair remaining in that box. That leaves us with 2, 3, and 4 remaining in row 4. And we guaranteed a 4 here, so this is either 2, 4 or 3, 4, which adds up to 6 or 7. Either way, 4 has to be here. because it must be increasing to here. This digit cannot be 2, 3, or 4. If it's not 1, the problem is where can 1 be? This digit is descending. It can't be here, can't be here, can't be here, so 1 has to be here. So 1 and 5 add up to 6, but we can't have 6 here because of 6 in the column. 1, 6 here. Could be 1, 7 adding up to 8, or 1, 8 adding up to 9. Either way, one of these is an 8. This cannot have 1, 2, and 3, so this must be 4 and 5 to add up to 9. So 4 and 5 add up to 9 there. That eliminates 9 here, so it's 8 and 7. That leaves the remaining digit in column 1 as a 5. Remaining digits in column 2 are 6 and 7. This can't be 7 because of 7 in the box, so that's 6 there, 7 there. Remaining digit in this upper left-hand box is a 9. That leaves us 6 and 8 remaining in column 3. This can't be 1 or 2, so it's at minimum 3. This cannot be 4 or 3, so this is at minimum 5 because of, so that means this is at least 8 or 9. Cannot be 8 because of 8 in the column, so that's 9 there. So this must be either 3 and 6 or 4 and 5 adding up to 9. Where is 3 in column 6? Can't be here because of 3 in the boxes. Can't be here because of 3's in the row, so 3 has to be here. So this must be 3 and 6 here. 6 eliminates 6 here, so it's 8 and 6 there. Where is 1 in... So this, again, has to increase. You cannot, if you don't have 1 here, that would mean this is at minimum 5 and 6, which doesn't add up to a single digit, so 1 has to be here, 1 therefore has to be there. You cannot have 1 and 5 adding up to 6 because of 6 here, no 1, 6 adding up to 7, no 1, 7 adding up to 8, so this must be 1 and 8 adding up to 9 there because of 6 or 7 in the row. That leaves us 4 and 5 remaining in row 9. 4 eliminates 4 here, so it's 5 and 4. We are left with 7 and 5 remaining in row 8. This can't be 5 because of 5 in the box, so this is 7, that's 5. 7 eliminates 7 here, so it's 5 and 7. Remaining digits of this lower central box are 2 and 8. 2 eliminates 2 here, so that's 8 and 2. That leaves a 9 remaining in column 4. Remaining digits in row 7 are 6 and 7. 5 eliminates 5 here, so that's 8, which makes that 9, so no 9 there. 8 eliminates 8 here, so it's 5. Remaining digits of column 5, we have 7 and 6. 7 can't be here because of 7 in the row, so that's 6 and 7 there. Column 6 can be 4, 5, or 8. Okay, no 5 here, no 8 here, and no 4 here because of the digits in those rows. This digit must be greater than that, so it's at least, it cannot be 3 or 4. So it's at least 5. Well, this cannot be 6 or 7. It can't be 8 because 1, 2, and 8 at minimum add up to 11. So this is guaranteed to be 5. 1, 2, and 5 add up to 8, but we can't have 8 there because of 8 in the column, so this must be 1, 3, and 5 adding up to 9. 3 eliminates 3 here, so it's 2 and 4 adding up to 6, which makes this 7, which makes that 6. 6 eliminates 6 here, so it's 7. 2 in column 7 cannot be here because of 2's in the rows, so 2 has to be there. 5 eliminates 5 here, so it's 8. Remaining digit in row 3 is a 1. We have 2 and 6 adding up to 8 here. 8 eliminates 8 here, so that's 4, which makes this 5. And the remaining digits here have to be, this must be 4. This must be 3, and that must add up to 7. Yeah, this is pretty straightforward. It's basically just thermometers on arrows, which are very restrictive. So it's not going to be hard to figure out what these sums have to be. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.